Okay, so these are nuclear equations, and what we have to do is figure out what X is, the missing isotope. Because the law of conservation of mass says that the mass before has to equal the mass after, we can treat the arrow sign as an equal sign. So that if we look at the top numbers, we have 238 equals 4 plus X. So the top number for X then has to be 234. And if we look at the bottom numbers, 92 equals 2 plus X. So the atomic number has to be 90. Mass number on top, atomic number on bottom. So we use the bottom number 90 to look on the periodic table and see that this is thorium. So the missing isotope for my reaction is 234 thorium. Now also in this I can tell that this was alpha decay, and I know that this is alpha decay because this helium isotope represents alpha. In our second example, for the top numbers we would have 208 equals X plus 0. So for my missing isotope it would have to be 208 for the mass number. On the bottom you have 82 equals X, and then you have plus a negative 1, so it's really minus 1. So the bottom number has to be 83. Watch out for the negative electron there. So that means this has to be bismuth. So the missing isotope then is 208 bismuth. Now I know that this is a beta decay this time because of the electron. So if it has the helium nucleus or isotope, then it's an alpha decay. If it has the electron, then it's a beta decay. Now in our third example, we're actually missing these numbers at the bottom, but hopefully you realize that those bottom numbers are the atomic numbers. So we can look on the periodic table and see that helium is element 2 and Pa is element 91. So then we would say X equals 4 plus 234, so my missing isotope has to have a mass of 234, and that X equals 2 plus 91, my missing isotope has to have an atomic number of 93. I look for 93 on the periodic table, and that is neptunium. Because we have this helium isotope, I know that this is another example of alpha decay. Fission is when you take an atom or take the nucleus of an atom and split it into two. So fission, division. Fusion is when you take two nuclei and combine it into one. So fission, division, fusion, combine. If we look at the example that we just did here with uranium, we have one isotope and then we end up with two isotopes. So that is an example of a fission reaction because we're taking one and we're splitting it into two. Decay is a random event that can't be changed by outside intervention. So you can't take something that's radioactive and freeze it. You can't take something radioactive and burn it in order to stop the fact that it will be radioactive. The decay happens no matter what. It's independent of any energy changes. Half-life is the time required for half of the atoms to decay. The actual substance doesn't matter in these problems. The half-life is 8 seconds. If we begin with 80 grams, so 80 grams is what I'm starting with, how long will it take before only 5 grams remain? So 5 grams is what I'm ending with. And because I'm looking for how long, I know I'm looking for the total time. So we start with 80 grams, cut 80 in half, and that would be 40. Well, the half-life is 8 seconds, so the time it takes for that to be cut in half is 8 seconds. 40 cut in half is 20. So it would take an additional 8 seconds to get down to 20 grams. Half of 20 is 10. That takes an additional 8 seconds. And then half of 10 is 5 grams. That took another 8 seconds. Now that I'm at the end point of my problem, I can stop. And then 8 plus 8 plus 8 plus 8 would give me 32 seconds. Again, the isotope that's being referred to doesn't matter to our problem. We have a half-life of 15 hours. we have 2 grams after 45. So 2 grams is what I'm ending with. 45 hours would be my total time. And how much must we begin with? So I'm looking for my starting amount. So instead of cutting things in half this time, I'm going to double them. So 2 doubled is 4 grams, and that took me 15 hours. Well, the total time is 45 hours. 15 does not equal 45, so I know that I have to double this again to 8 grams, which took 15 hours. Well, 15 plus 15 does not equal 45, so I have to double again to 16. Now, 15 plus 15 plus 15 does equal 45, so I know my answer is 16 grams. And then finally, we don't worry about the isotope. It decays to 26.25%, so this is my end point. Now, because it's a percent, I know that I have to start at 100%. It says that the activity is done in 18 days, so this is my total time. And I'm looking for the half-life. So if I start at 100, half of 100 is 50. I don't know the half-life, so I'm going to use x. Half of 50 is 25. Again, I don't know the half-life, so I'll put x. Half of 25 is 12.5 plus x. Half of 12.5 is 6.25 plus x. So 6.25, I've reached my end point, and I know that all has to equal 18 days. So I have 4 half-lives, or 4x, equals 18 days. So 18 divided by 4 gives us 4.5. So my half-life is 4.5 days.